you want to pull it up online, cut that down.
You know what kind of problem it was? Oh yeah, somebody gave me this here. So somebody had this here. All right. So what is there to be done first? Look at factor. What do you have to make sure you eventually do at some point?
Flip them up.
Flip it, because it's division right now, right? So then I got, what can I do here? I'm going to give that away. Can you factor this?
No.
Why not?
Because it's a
Sum of squares, right? So it's exactly, you can't factor it for the exact same reason you can factor a difference of squares. The plus doesn't let you have different signs. And then how do you factor the top there? Good. Plus 5. Minus 3. How are we doing there? Are we okay so far? And then what cancels? And you see the evilness they're trying to make you do? They're trying to make you do this, and you can't do that. So that's the answer. It's just that times that over that. That's the answer. Just because there's a c minus 3 part doesn't mean you're supposed to be able to factor c squared. That's just, them being tricky. Okay, cool. Anything else from homework?
So the answer is?
Yeah, so the answer, c minus 5, c squared is 9, over c minus, you just collect all the survivors together.
But I get the same thing, and then I put it, and just still give me wrong.
So there's you can contact your instructor. You're talking about online, right? Okay, so this is, now you see why, it's got a lot of cool built-in stuff, MyMathLab, and there's something else called WebAssign that I use with some of my other classes. And I just do it because so many people are doing it nowadays. Most of my colleagues are doing it just so they don't have to grade homework. I don't blame them too much. But at the same time, all it takes is a couple of those kind of things to frustrate the hell out of a student who's just barely hanging on to the math stuff, and that's why I don't make it mandatory. I make it totally optional. If you run across something like that, you've got to email me through MyMathLab. There says contact your instructor or something, right? When there's a problem with one of the problems. And if it really is a technical issue, I can contact Pearson and say, hey, fix this. And then I can make it worth 0 points if it really is wrong. But most often when I get those, the student doesn't realize there is something a little bit different about what they're trying to put in. You guys got anybody who's in the online homework? Don't just take it. Don't just take it if it's telling you you're wrong when you know you're right. Let me know, or else I can't do shit about it. Okay.
I have a question.
Yeah.
7.7, number 18. Section 7.7, page 48.
Number 18.
Mm-hmm.
Steve and Bill out paving driveways. So let's see. Together. So in general, it's 1 over the time for one person, and 1 over the time for somebody else is 1 over the time for together, right? Aw. That's the general idea. So together, Steve and Bill require 4 hours and 48 minutes. Alone, Steve would require 4 hours more than Bill, because Steve is just that way. How long would it take Bill to do the job alone? Convert minutes to hours. It's not a bad idea. Alone, Steve would require 4 hours more than Bill. So Steve's time and Bill's time. Who's going to be just X? Yeah, Bill, because Steve's time is 4 hours more than Bill. Steve's time depends on Bill's time. So I got to call Bill's time X first. And then Steve's time is 4 hours more than that. X plus 4. So where do these two things go?
Under T1 and T2.
Yeah, these are the individual times, and then together would go this. And they told you a good hint is to convert to hours, especially because 4 is in hours. You want all your other time in hours too. Now you could go the other. You could convert to minutes if you want to have 288 running around in your equation, right? That would be 280 minutes. How much of an hour is 48 minutes?
4/5.
Yeah, how did you get that?
I'm trying to remember.
So 48 out of what to make this total? 60. So 48 minutes, if you reduce this, is 4/5, right? So that's 4 4/5 hours. So I think the hard part of this problem is just dealing with the 4 hours and 48 minutes, right? Would you guys rather change to minutes?
Yes.
Sure? Okay. Let's do that. Screw the book. Say, book, you're screwed. So what do I have to do with this, though? I can't put 4 there. Yeah, 4 hours would be 240 minutes, right? And that pretty much tells me what to do here. That's 240 minutes plus 48 minutes is 288 minutes. How are we doing so far? So then I don't have to deal with fractions, right? So you go to the smaller unit to not deal with fractions, because now you're multiplying stuff to make it bigger. So now I got, what does the equation look like now?
1/x plus
Good.
240.
So you do one job in that much time, and Bill can do one job in X hours, and together they can do one job in, not hours, sorry, minutes, 288 minutes. Now that looks a lot like, stuff you're just doing. Just give everybody what they're missing. So it's a trade-off. You don't have to deal with this 4 hours and 4/5 hours, but your numbers are bigger.
And in that one, if you get a negative number, there will be no solution for that part.
You can't.
For one person, might be negative when the other one is. Because once you get.
That would mean if you call them, the job gets done 10 minutes before you call them. You understand? Negative time. Let me start. It's done. No, time to make the donuts. Sorry, I made the donuts. So that's Carl's like around my age. You might remember that. This shouldn't come out negative unless the book made a mistake setting this up. So what's he missing? He's missing a couple things. He's missing an X and a 288. He's missing 288 and X plus 240. How are we doing so far? I'm just giving each one what they're missing. Of course, this guy needs X and X plus 240. It's annoying. All right. Well, and then you can kill the bottom. So you got 280x plus 288 equals x squared plus 240x. So our decision to go the other way on the units, we have to deal with these big numbers now, right? So if I kill all the bottoms, I'll get 288x
Plus 288.
plus 288.
Plus x squared.
Yeah, x squared plus 240x. It's distributing that x through on the other side.
But see, when you do that, you're going to get x. You have to factor.
You're going to get two answers.
Yes.
One of them will be negative.
Yeah, that's why.
Throw that one out.
Okay.
So earlier you just said you got a negative answer.
No.
You're going to get one negative answer, which you obviously throw out.
Okay.
Yeah.
That's fine.
Math doesn't know I'm talking about real world stuff, and math just says this number makes it work, and we're like, that negative time would be freaky. That'd be nice. You just have to start to think about doing something, and it's already done an hour ago. Right? That would be kind of nifty. So to solve this, you just get everything
In the same.
on one side. Subtract 288x. You got x squared minus 40x. Subtract 288. I just need numbers that multiply to be 288 and add to be 48. Well, I need two numbers. 27 won't go into 288. So what I would do, here's two numbers that make 48. Negative 50 and 2. Do they multiply to 288? You see where I'm getting those? Instead of factoring 288, let me start with two numbers that add to negative 48. I know they're going to be different signs, aren't they? I know they're going to be different signs. They're going to multiply to negative. So that's not enough. All right, let me try negative 60 and what would make 48? 12, right? Doesn't that make negative 48? So I just need two numbers that are 48 apart, and then I can check. What's negative 60 times 12? Negative 720. You guys have calculators. So it's somewhere in the middle there, isn't it? You guys start to see this is now as like a Price is Right. Higher, lower, higher. So then maybe in the middle, negative 54 and 6 would make 48, right? And what's negative 54 times 6?
324.
I'm getting close. Negative 52 and 4. So that'll make negative 208. Negative 53 and 5 will make 265, so nothing works. That's an evil problem. I don't like that problem. I don't see where we made a mistake. So maybe it's a problem's problem. Negative 48, negative 288.
Is it the plus 1 for x?
What about? Oh, that's
Because
it.
I was looking
Right
on my
there.
paper. Yeah.
That needs to be up here also.
Okay.
Okay.
I kept going over. I'm like, maybe I'm missing.
No. Please say something.
Okay.
The minute you think I missed something, I am not going to come down on you. I'm going to go, oh, okay. Or if I got it, I'm like, no, it's all right, I got it.
Okay, because I kept going over.
Please don't let me get here.
Yeah. I'm like, how did you get?
And at the same time, I love it when students take that to mean something about what I know. I mean, I'm a human. I'm going to make a mistake. So point it out when I forget somebody. I wrote him on the bottom, but I never wrote him on the top.
Yeah, because I was like, okay, I see 20.
All right. So now it should work out when you get all your stuff together on one side, get numbers that work. Now it should factor. Cool. I was going to contact the publisher. All right. Anything else from homework? Oh, I'm over this one. You got the idea now. Now instead of just a 288, you'll have 288x plus 288x times 240, whatever that is.
Yeah.
Okay.
Yeah. And again, this is because we chose to go to minutes instead of hours. That trade-off is making us deal with larger numbers. So if you get to this point, you're like, I don't want to do that anymore, go back and make everything hours, if you want to. All right, it's up to you. But, I mean, you can attack this problem now because you know what to do. You get everything together, get it equal to 0, try to factor it. You've got calculators, so it'll help you factor the numbers that you get. Okay. Is there anything else from homework that I can almost set up right? Okay. Homework is it's obviously the best way to get ready for a quiz. Homework is also, it's really, really just stupid to cheat in any way on homework because it's not worth enough, but it is worth something. So it's not good to not do it either. So the whole purpose for why I assign homework is to give you enough practice so that you can actually get things learned, right? So you all know just sitting there listening to me doesn't do much for you. At some point you actually have to do it. So if you don't do the homework, I just don't understand you. Or if you cheat on the homework, not only do I not understand you, but you also piss me off, right? It's not a good thing to do, right? Because they got honest people working hard, and they got you trying to pull something over me. No. So I'm not talking to everybody. There's a few of you guys I'm a little worried about, but not everybody.
How do you cheat?
Just find the right people in here.
Oh, no, true.
They actually don't find the right people in. They're not doing it well enough. It's not getting past me. But there's a whole underground movement here at every company. It's amazing what they think they know that we don't know.
So chapter 7 and chapter 12 is due for by the next exam.
Exactly. So I'm not sure yet if we're going to make it all the way through 12. So I'll just let you know how much homework is due, and then whatever we don't get to will be on the next test. Yeah. So getting back into 12, the last thing we were looking at was how to rewrite something like that. How do I rewrite that as a power?
We still have 12.2, right?
12-2.
Just
Power of 1 over there.
Good. X to the 1/2 power. And it makes so much sense. On one level it makes sense because if you actually do it like we did the other day, if you actually do it as numbers, like the square root of 49 is supposed to be 7. And I'm claiming that that's exactly the same as this. That's my claim, that the square root is exactly the same as a 1/2 power. And what did we do yesterday to show that that's true? We took 49 and wrote it as, not yesterday, but you know.
7.
Couple days.
Couple of
7.
7 squared. And what do these do?
cancel.
Because you multiply them, right? You multiply in that situation. So 2 times 1/2 is 1, so you do get 7. So 1/2 of 49 multiplicatively is 7, which is exactly what a square root is asking you to do. Cut it in half multiplicatively. Carl. You have the funkiest face. I don't mean in general, I mean right then you did. Alright. But does that make sense on some level? And what does a square root do to a number? It cuts it in half. Right? Like you do when you do a difference of squares. You cut everything in half. When you do cubes, they cut everything in thirds. You get on the track. So if I had the cube root of 8, 2, because 2 times 2 times 2 is 8. So that 3 out there doesn't mean 3 into 8. It means break 8 up into 3 multiplicative parts, 3 factors that are all the same. So that's 2. So if I ask you to do this, why does that kind of mean?
Because that is only 3 of them.
I love it. I love the way he said it. I can't take the cube root of 9. There's no good, nice number that multiplies by itself 3 times 9. There is a number that does it. There is a cube root of 9. If you figure out how to do it in the calculator, you'll get a number. But it's not like 2 or 3 or 4, right? It's like 2.1574659. And really, another good way to look at it is how many parts of 9 are there? If you break it up, there's only 2 parts. And what does a cube root need? 3 parts. I love it, love it.
So for that you put no.
You just say can't simplify further, right? Yes.
So that won't be to a power?
So if they say rewrite this, it depends on what they ask. If they said simplify this, you could say already simplified or can't do anymore. If they said rewrite this as an exponential form, using it as an exponent, how would you rewrite this in exponential form? 9 to the 1/3 power.
Oh.
Because a cube root is a 1/3 power. It cuts things in thirds. So a 4th root is a 1/4 power. It's crazy. So we even got, I think we got to the point yesterday where we were looking at stuff like this. So I know the cube root of x, I could write that as x to the 1/3. What about cube root of x squared?
5.
Alright, so x squared to the 1/3. But then what can I do with those powers?
2/3.
Become a 3. Okay. 2/3. Now look what that says. On the bottom of your power is the root. Roots are on the bottom of plants. Right, that's where I said any botanists out there, they'll come at me with, well, actually the 2 roots are actually root. No, screw it. Most plants have roots on the bottom. And the power is powerful, it's up on top. Bam. So if I try to go the other way, right, I'm going to try to do this the other way. Instead of starting with a root and making it a power, let's start with a power and make it a root. That's a sentence you won't hear very often. So if I said the cube root of 27 to the 2nd power, how would you rewrite that as a what did I just do? I want to go the other way. I want to go the other way, don't I? Yes. If I had 27 to the 4/3 power. There we go. How do I write that as a root? What's the root? Yeah, again, what's on the bottom of plants? Roots. So what's on the bottom? Power? Roots. So third root, 27. Now you could put the 4 there, but I don't want a fourth power 27. I'd much rather fourth power the answer. Because what is the cube root of 27? Beautiful, because you break 27 up into 3 parts. Multiplicatively, it's 3 times 3 times 3, right? Like we did earlier, we did that cubes with the 27 in it, we 3 through 3. Same idea, so that's 3 to the 4th power. 81. 3 times 3 is 9, times another more 3s, a couple more 3s is another 9, 9 times 9 is 81. What did I just say? 3 to the 4th power is 3 squared times 3 squared, 9 times 9, 81.
No, I'm saying from the top.
How do you break it down further?
You went from one to the next, then from there down one. Is
Exactly.
what I'm saying.
Okay. I
Yeah.
couldn't tell if you were requesting something from me or just saying stuff. Okay. So what about this here? 8 to the negative 2/3 power. Here's where people freak out. But a negative power just means what?
It's 1 over.
Good. You don't flip 2/3 and make it 3/2, right? Is 2/3 being raised to a negative power? No. So there's no reason for it to flip. What's being raised to a negative power? 8. So that's going to flip over, make it 1 over 8 to the 2/3 power.
Why did you do that? Why did you do that?
Because of negative.
We all remember
Yeah.
that a negative power means flip.
Yes.
I know I said that as a statement, but I should. Do we all remember that a negative power means
right
flip?
now, you look at it, 8 over 1. I get it.
Yeah. Yeah.
Right.
So this is over in 1. Always everything's over 1. So this wants to go down.
Negative to the bottom, okay.
Yeah. Negative powers
So
flip.
then,
Cool. And now you do it like we just did, but everything's going to happen on the bottom. So this would be 1 over, now what's that root? Cube root of 8 squared. What's cube root of 8? 2. Squared? 4. That's how you do the steps to get to the answer. So negative power doesn't make something negative. A negative power makes something flip. Right, so be a little careful. Now, another consequence of realizing this, that powers can represent roots, is this. You can make it 3. Let's do it 4. There you go. Rules of math never change. Just the stuff you stick in them do. Right? So what do you do when you multiply like bases?
So,
Add the powers. And in this case, in order to add those powers, what do I need? Common denominator. That's right. So you get x to the 1/4 plus 2/5. If I just write the rule, add the powers when I multiply like bases. Now I can focus on that problem by itself. Right? So the LCD there is 20.
what about the other?
Don't worry about it. It's just
So
1
it's
times 1.
13 over 20?
Yeah, 5 plus 8. Focus on one problem at a time. Now what was that?
Yeah.
Well, I asked about the other x.
Your x.
Or you just got.
What other x?
That's 1 times 1.
What other x? So what's x squared times x to the 5th?
Okay.
Yeah.
X to the 7th. I really want you to understand. There are not 2 x's here. There aren't. There's 2 x's there and 5 x's there, so what's a better way to write them? 7 freaking x's. So here's 1/4 of an x, and then there's another 2/5 of an x. So how much of an x do I have now? 13/20. So I've almost got a full x. Yeah. Do you guys understand?
Yeah.
So the rules don't change. The rules don't give a shit that there's fractions in there. The rules say you add whatever the hell's up there when you multiply like bases. So of course, when you divide, you... Alright.
All this hard work.
That's right. What's x to the 7th divided by x to the 4th?
You,
Oh, 7
Just
minus 4.
Good, right? So you just needed something to look at. X cubed. That's when you divide like bases, you subtract. Yeah, so, you're going to have problems like x to the 11 12ths divided by x to the 3/4.
Common denominator again.
Yeah. But again, if you want to, you could either just make common denominators right now, right? Or you can write it so like I did here, you'll just have a minus in the middle. Either way you want to do
Is
it.
it easier just to make the common denominator now?
Totally depends on the way you want to look at it.
Now, how you know which one is bigger?
You don't. Well, yeah, you kind of do. This one's definitely going to be bigger. Believe it or not. But even if you don't know, who cares? If at the end it comes out negative, you're going to flip it. Then you'll know, oh, the bottom was bigger. It doesn't matter right now which one's bigger. But it's a good point. You don't need to know, though. But what LCD?
12.
So this guy needs 3. So I get 11 minus 9, 2 12ths, which is 1/6. So it turns out the top one was bigger because I had positive left over. But I didn't need to know that. What's another way to say that? X to the 1/6.
power of the 6.
What's a 1/6 power also known as? What's a 1/2 power also known as? Square root. So what's a 1/6 power also known as? 6 root. So you can also write this as the 6th root of x.
Yeah,
Those are the
that's
same things.
Yeah.
I like that. That's what I meant.
It's what I was thinking when you asked that question. I just didn't know.
Actually, somebody said it to me on the test. I know I wrote that, but actually, I remember what you just said. Oh, I'm sorry. Just sorry. Let me change that grade for you. Down a little bit. All right. So what about this?
If, I have a question. If that one would have been negative, because the bottom would have been here, we just split it?
Yeah. So the answer, it's convention to not stop at a negative power. Whatever has a negative power, you put it to the other side. So if it's on the bottom, you bring it up. If it's on the top, you bring it down. Cool. So what about this here? What, Jeff? No, yeah. To the, what you got, Jeff? I don't know anymore. I had something. I like it.
Then you
Okay,
can
can you reduce it? Can you reduce it? Can you?
Yeah, you can.
The
I didn't
8
mean
to
that.
the,
Screw it.
Okay, we just
3
know
and
that.
3 and then 3 and 9. Can you do that?
So in general, yeah, what are you supposed to do with these powers?
Multiply.
Multiply. So it's just going to be 3/8 times 24 9ths, and then you start going to town. 8 goes into 24. 3 times 3 goes into 9. 3 goes into 3. So you get m to the 1. Yes. Well, you know the rules of powers. Just because I put fractions in there doesn't mean the rules change.
Isn't it something equals 0?
Yeah, I was just gonna say
What's the matter? What?
to 0.
M to 0 will be 1, right?
Yes, but that has nothing to do with the problem we just did, right?
Okay.
The problem we just did, we got m to the first, so there is one m sitting there.
Okay.
It's just n.
M to the 0 is 1 because if I had m squared over m squared, subtract those, what do you get?
M to 0, 1.
And of course, divide them,
It's 1.
they would cancel the 1. So no m's is a 1. Yeah. And another way to look at that, if m to the 0 is 1, when I multiply by m to the 0, the thing better stay the same, because isn't that what 1 does?
Mm-hmm.
So if I have m cubed and I multiply by m to the 0, what do you do with the powers?
Multiply.
Add them.
Yeah.
So 3 plus 0 is... So what did this do to this?
Nothing.
Nothing. It did just like 1 would. 1 would multiply this and leave it alone. Well, he just multiplied that and left him alone. What's the only thing that does that? 1. So it's another kind of proof that that's 1.
What made 0 equal 1?
I never said 0 equals 1.
No, I mean like m to the 0. What made that?
But I just did this. What's 2 minus 2?
Oh, that's right.
0. But another way to look at this is that divided by itself is 1. So those two things came from the same place. They have to be equal to each other.
For m to the power 1, can we just put n?
Yes, yes. I just put 1 just to make a point that that's what it is. Okay, cool. Maybe.
There's still 12.2.
This is still 12.2. Yeah. 12.2 introduces the idea of fractional powers, and then you just start doing everything you can. So there's actually not that much new. That's it. That's the only new thing. And then they go, oh yeah, remember all the old stuff? Works the same damn way. You add them, but if they're fractions, you need LCD. Right? And the rest, what we just did there, you can cancel, go to town, you're supposed to multiply these. How we doing? Shoot, now you're turning into my other classes. Shit. Don't let them know. Yes.
So the answer would be m to the 0 equals 1? Like that's the whole answer, or would it just be 1?
Wait. So these are two separate things here, right?
Yeah.
Okay, good. So this is a proof. M to the 0 wouldn't be good enough, because M to the 0 is 1. So the answer would be 1.
So why would you not put the m?
Because there is no M's. What happened to the M's? They
Okay,
all
that's
canceled,
true.
right?
Okay.
So that's saying there's no M's. So what's the only thing that can be there then? That little 1 dude.
Okay.
Right? So really, that's another way. That means there's no M's. Well, what's there then? 1. So I wouldn't write the M because there's no M's. You have that look, if you tell, and it's like, I almost get what you're saying.
Well, yeah, you say cancel out. And
Yep.
there only be one left.
So that's one way of saying there's no M's. That's a better way to say it. You would just be left with the 1 that you get when you cancel stuff out. Okay, good. So what's this?
1.
Yeah. What's this?
2x.
Beautiful, because only that's 1 times 2x is 2x. Right? Only the part that's being raised to 0 power becomes 1. So what's this? What you got, Jeff?
X.
I don't know.
2. Negative.
Yeah, so this is 1. This is 3 times 2 to the 0 is 1. So your 1 minus 3 is negative 2. So only the part that's being raised to the power gets affected. So that's why when sometimes I'll see people with the negative powers, there'll be a problem like m negative 2, let's say 2m negative 2 over, let's say this, I don't want to get into x over 3m. And on the next step, I'll see this. Now they almost got something right here. They just went too far with this.
2 doesn't move.
Yeah, the 2. Why would the 2 move? Is it being raised to a negative power? What power is it being raised to?
1.
1. What's the only thing being raised to negative power? So that shouldn't go down there. That should stay up here. Right? Only the part being raised to the power gets affected that way. Okay, maybe. Oh yeah. This class goes by quick. Well, for me. For you guys, it's probably... I don't take it personally. That's the way it is. So one last thing in this section. I desperately want to get into a little bit of new stuff before we get there. What could I do with this? I mean, that's not too bad. We've looked at stuff like that before.
X
6 over
parentheses. X to 6 parentheses 1/3.
x to 6.
Sort of. A more direct way to rewrite this is x to the 6,
3 over.
which is x.
2.
Yeah.
We let that sink in. Isn't that how you rewrite powers and roots? Roots on the bottom, power on the top. So it's just x squared. And it makes sense. Cut this into 3 parts. And what do you get? What we got, x squared, right? If you cut 6 x's into 3 groups, how many is in each group? 2x. That's what that's saying, right? Okay. So what if I turn that around? I love it. That'll be x to the what power? Which you can reduce to
1.
So the 6 root of x cubed is the same as what root?
Square root of x.
Root of x. Okay, baby, because we cut 3 things into 6 parts. Each one you're going to cut in half. That's really what it's saying. Cool. All right, maybe. So one last little thing there. That section. If I say that phrase, you guys will start packing up. I'm not done yet. 5th root of the 4th root of.
What?
What?
Oh wow. So that's.
I love you guys. There is allowed a spirit of exploration in mathematics. Yes. So look at what I'm saying. I want to cut something. Think of a pie. You got a pie in your brain? All right. Your favorite pie. If you don't like pie, a round cake. Looking from the. I cut it into 4 parts, and then I cut all those into 5 parts. How many parts am I going to end up with?
4.
A lot.
So you put x.
Now let's do this mathematically. Rewrite the inside for me. Let me leave the 5th root on the outside. Just sitting on the outside. How about I rewrite a 4th root? It's x to the 1/4. Now, that's the 5th root of this thing. So that would be that thing to the what power? For a 5th root? 1/5. You with me? Because they're each roots. So 1/4 for the inside root, 1/5 for the outside root. What do you do with those powers? Multiply, you get 1/20. And if you think back to what I was trying to say earlier, if you cut something into 4 parts and then cut it all those into 5 parts, you get 20 little tiny parts. You give them to your 20 kids, and they're all going to be upset. He's small. Don't have 20 kids. That's the moral to the story. Because then you got to
Multiply those two numbers.
say again. Yeah. So that's the shortcut. That's the shortcut.
Yeah, can you do that?
Yes. 5 times 4 is 20. It's 23. Now, I want you to realize I'm not going to teach you that from the beginning. I want you to realize, because that's what's going on, and then you realize, oh, there's a shortcut to this, but you see the math behind the shortcut. I never teach shortcuts directly because it's not good. Then you don't understand why the hell it works. You just say, it's 7. Why? I just know it is. So what good is that? Okay. So a little bit of new stuff, and then I'll let you guys out. Tiny little bit. So help me out. Remind me, if I had AB squared, this is 12.3. If I had AB squared, how could I rewrite that?
A square, B square.
Beautiful. I can distribute the square, right? So I'm allowed to do that backwards, right? So if I had like x cubed, y cubed, do it backwards, and what do I get? Nobody's to the 9th power, right? But they're both to the 3rd power. Now what am I doing that for? Well, because, right? Square root of x times square root of y. Isn't that x to the 1/2, y to the 1/2, and what did we just do?
Put it on together.
So isn't that one big old square root of...
X and Y.
Now, before anybody shouts at me about anything, this is why it works, right? This is why it works. I wouldn't do those middle parts. I'm allowed to multiply roots together. Why was I able to do this part here? Because these were both the same. If they were different, I couldn't do this, could I? There wouldn't be anything to take out. They'd each be different. So if they are the same root, don't do that work. You can just multiply them together. So for example, if I had...
4 and 5.
Huh?
4 and 5.
4 and 5. So what you're saying?
Yeah, 4 and 5.
She's giving me the numbers.
Yeah, I don't want to use those numbers. But square root of 4 is 2, so I wouldn't leave it in a root. So But if I had square root of 7 times square root of 5, so I use one of your numbers. That would be the
Square of 7.35.
square root of 35. Let me stop right there. You guys with me?
Yeah.
Because of this, I don't have to do that anymore as long as the root is the same. In fact, we've done that forever. What's 7 times 5? I'm allowed to multiply them because they both have no root. They have the same root, meaning none. Right? So now, as long as they both have a square root, I can multiply them. If they both have a cube root, what's the cube root of 4 times the cube root of 2? Cube root of 8, which is 2. Yeah.
I have a question, but if you put X and Y, say, and you know how we had those problems where you had to take a -1 in one of the X or the Y? If you have X plus Y, cube root of X plus Y and the same root, X minus Y,
Okay, sure.
and you take out the minus, would you have to count the
So let me try to make sure. Are you saying you have like square root of X plus Y, square root of X minus Y?
Yes.
What would that be?
Well, you take out the -1 in one of them, it will be X plus Y square root times -1.
No, you're thinking. If I take a negative out, it's not going to be the same as that.
Yes.
No.
Would you do it like that or not?
I'm not sure. All I would do here is do what we've been doing, which is multiply that by that on the inside.
Oh, okay.
So it'd be the root X plus Y, X minus Y. Now, I think you might be talking about something, and you can make that X squared minus Y squared. Is that cool? Because that's like a difference of squares. Right? Now, be really careful. I'm kind of glad this came up. This is so desperately not X minus Y. No. Right? We know this. We know that if I gave you this, and somebody told me the answer was this, what would you say as the teacher, if you were the teacher? Would you say, that looks good? What's wrong with that?
But it's not like that. It's like
They didn't do what? Or it doesn't look good. Maybe it's right. Maybe I'm tricking
you
you.
get into the middle.
No, it's not middle term. They didn't FOIL. They thought they could take the square and distribute it. But of course the square won't go across plus, because what's a square based on? What operation? So if it was 2x squared, I could distribute it all day long, because that's a square, and that's a multiplication. They work well together. Square and addition, no. Right? So this, I can't distribute the roots of both. I can't do the square root of each piece. Right? I can't say that the square root of 16 plus 9 is 4 plus 3. That's not true. Do you see where it came from? Square root of 16 is 4, square root of 9 is 3. Nowhere do I say that, though. So this would be 7. But what's 16 plus 9? What's 16 plus 9? 25. And what's the square root of 25? 5. So no. So a square root cannot distribute to the parts. It won't. For the same reason that a square won't distribute to the parts of a sum. Everybody's looking up there. It's not quite time. So last little thing. If I can go that way, I can go the other way. Tell me, can you take the square root of 50? What can you take the square root of? It's really close to 50. 49, yeah, I know where you're going. You're going the right way, but not yet. Square root of 49 is 7, so square root of 50 is going to be a little bit
7
more than 7, like 7.0 something, right? But that's not good enough. I want to know exactly what I want to simplify this. But I can't do the square root of 50. So what you do is break it out. 50 is 25 times 2. Now it's also 5 times 10. But that's no good. Why is this better? Because I can do the square root of. So I just do what we've been doing in reverse. Break this up. Do the part you can do. Don't do the part you can't do. So square root of 25 is 5. Square root of 2 is, I don't know. So that's what I call reducing a root. It's not quite the right terminology, but I like it. Because it is a lot like reducing a fraction. You do the part you can, you leave the part you can't. So it's a lot like 18 over 7. Can I divide 7 into 18?
No.
No, but I can divide 7 into a part of 18. If I make this 14 plus 4, 7 goes into 14, and I have 4 7s left over. That's how you change into a mixed number. But doesn't that should feel a lot like what we're doing? I can't do 50, but I can do a part of 50 and leave the other part stuck over the thing, or under the thing in this case. So this is simplifying a radical is what they'll say. I might say reduce the radical, or something like that when I talk about it. And that's still a part of 12.3. So 12.4 is just dividing radical expressions, which are really a lot like what we just did. Just with one extra little thing called rationalization. So we'll get into that next time. And I'll have the quizzes graded. Have a good weekend. I just have a